In Section 3, we will discuss evaluating polynomial and rational functions. We can use function notation to represent polynomials. For example, p of x equals 2x cubed minus 3x plus 4. Evaluating a polynomial for a particular value involves replacing the value for the variables involved. We can find the value p of negative 2 equals 2x cubed minus 3x plus 4. Remember, anytime we put a number in place of x on the left-hand side of the equation, we do the same thing on the right-hand side of the equation. So this would become 2 times negative 2 cubed minus 3 times negative 2 plus 4. Once we correctly substitute the value in place of x, we evaluate. First, we start with negative 2 cubed. This would become 2 times negative 8 minus 3 times negative 2 plus 4. We then multiply 2 and negative 8. We have negative 16 minus 3 times negative 2 plus 4. Now we multiply negative 3 and negative 2. We have negative 16 plus 6 plus 4. We can add one at a time or all together. Negative 16 plus 6 plus 4 would become negative 6. Function notation to represent rational functions. For example, t of x equals 2 plus x over x minus 4. A rational function is simply an algebraic fraction. Evaluating a rational function for a particular value involves replacing the value for the variables involved. For example, if we wanted to find the value t of 2 equals 2 plus x over x minus 4, then in place of every x on the right-hand side of the equation, we would put the value 2. This would give us t of 2 equals 2 plus 2, all divided by 2, minus 4. Starting with the fraction, we simplify the numerator. 2 plus 2 is 4 over 2 minus 4. 4 divided by 2 is 2, so this would become 2 minus 4, or just negative 2. In polynomial, find p of a, p of negative x, and p of x plus h. So there are some times when we replace the variable with a different variable, and this can be useful especially the further you go along in math. Let's try to do these 3 different examples. In the first, we will replace every x value with an a. This will give us p of a equals 2 times a minus 4, or just 2a minus 4. In the next example, let's replace every x with a negative x. And every time you plug in a value in place of another value, make sure to start by putting it in parentheses. So p of negative x equals 2 times negative x minus 4. 2 times negative x is negative 2x, so this becomes negative 2x minus 4. And last, let's replace x with x plus h. Remember, we want to put this in parentheses when we introduce a new variable into the problem. So 2 times, in parentheses, x plus h minus 4 equals, to simplify, let's distribute the 2. This becomes 2x plus 2h minus 4. So perform arithmetic operations with different functions. For example, if p of x equals 3x and r of x equals 3x minus 7, we can find the product p of x times r of x. To do this, we will simply replace the function notation with the polynomials. In place of p of x, we will write 3x. In place of r of x, we will write 3x minus 7. In order to simplify, we will distribute the 3x into each term inside parentheses. 3x times 3x is 9x squared. 3x times 7 is 21x. So the simplified product is 9x squared minus 21x.